my intentions and designs and solutions for the down gearing. That was a major, major important part of all this. The whole point of coming away from the servo motors that you buy is that they're just too big in every direction. They're not slim enough profile. And it was going to be impossible to put as many of those as I needed into my design. And what I've seen a lot of roboticists do is make the cases of those servos part of the actual structural framework of the arm. But then they're going away from having human bone style design, and the human bone style design is what I wanted in order to have it have all the excellent benefits of the human bone structure, such as the human bone strength, the smoothness of motion that having human bones has. It'll have way more realistic motion. It will look real the way it moves because it's using the same hinge system. All the measurements, everything's going to look human if you're not switching how the structure of all the hinges and everything are. It's going to look far less human in its motions. So I want to have a very human-like motion and movement in addition to the experience, the external appearance. So that's very important to me, and that's one of the reasons why the bones are excellent. Plus, the bones are just well designed. Just are so excellently designed. All the shapes, all the hinges, all the sockets, fantastic. So, anyways, if you want to keep the human bone shape and design, but you also need to fit an immense number of motors, which you need, then you can't have the motors coupled to the gears in the way that servos are designed. They're unacceptable. And so you have to, I believe, use a pulley system like I came up with. So I think that I finally, once and for all, solved this equation of the very best way to have a humanoid robot with a standard skeletal system employing the necessary number of motors, and yet being able to down gear those motors to be able to handle producing the necessary speed and torque requirements without the down gearing system requiring so much space. And one more side note is that the down gearing system with the teethed gears create a lot of chatter. It's like, and my robot's not going to have that. It's only going to have the sound of the noise of the motors themselves, the little static electrical bursts as the brushes rub against the commuter ring. I believe that's what it's called. It will have that staticky noise, but because it doesn't have all the gears, it's going to be way quieter, way, way quieter, which is my goal. And actually, the brushless motors, I think, are even quieter, but I'm not sure on that. I'm not actually sure on that, because I hear definitely my electric bike is like, but it's kind of a pleasant, it's not a measurable sound. Whereas when you got those geared teeth grinding, that's that. It's like, I don't know, it's bad. And I believe geared teeth, yeah, those are in drills as well. So power drills and servo motors, they all have horrible sounds. But when you just have that smooth, like a Tesla car taking off, or I mean, it's almost silent. But if you were to have your ear right next to that motor, it would be actually a pleasing sound. So we're going to be in a pretty good spot as far as the majority of our motors, which are going to be brushless. But as I said, brushed motors are being used for just the fingers, and I think it shouldn't be that bad on noise. But we'll see. It may come to pass that we end up switching to brushless motors for the fingers as a future upgrade, which would be a disaster to have to redo it all. But oh well. But we would have to find a smaller brushless motor than the ones I bought, the 2430 size. We'd have to find something about half that size. And I'm sure it probably is out there, but just to get me started getting all the fingers working, there also is the advantage of being able to work with with the simpler single H bridge. Um, for a brushed DC motor, it's much easier circuitry, and so that kind of gets me hitting the ground running, having less sophisticated circuitry to mess with. Um, but I don't know. See, how can I commit to saying, you know what, we're not using any brushed motors at all, let's go with brushless? How can I say that when it may turn out that these brushed motors are not too loud and they actually are more than enough? They're significant strength for the fingers, and I'm very happy with the finger strength, and they're very precise. And what if I love them? So it's like I lean toward using them just because I might love them. How strong does a hand's grip need to be? I'm not even sure. How will this compare to my hand's grip? I don't even know that. I don't have answers yet. So it's like, let's just go with these. They're a much cheaper option for now, even though money is not really a factor. I mean, we're talking about the difference between $1 per motor or $11. If it's $11 times, what did we say, 19 motors, that's a couple $100 for a robot hand. If this robot hand is going to be as good as I think, I mean, $200, that's peanuts. Um, Compares with the value to me of highly effective, efficient, excellent working robot hand. The value of that to me would be just immeasurable. I mean, literally, this thing will be able to do my chores. It'll be able to be a full-time employee for years to come. Like, that's amazing. Why not use stronger motors in the forearm than small motors in the... Wait. Oh, why not use stronger motors in the forearm and then small motors in the fingers? That's what I'm doing, but you're just tuning in. I am using the smaller motors for the fingers, but they're not in the fingers. Just because they're for the fingers, they don't have to be in the fingers, because the motors are going to be um, turning, winding up string, and that string then travels down the length of the robot's body to the joint where it's going to be actually moving that joint, like a muscle does. And so the motors are more like a fishing reel, reeling in fishing line, than they are an actual direct interfacer with the bones of the robot. They don't interface directly. So they don't have to be physically located where the joint is that they're going to be actuating. And that was a core element of the very start of my design, is that discovery that I could do that. So anyways, I think I covered it all. That was like a long update, but I had to cover a lot of ground. I mean, there's a lot going on, a lot of planning going on. So you guys might think, hey, he's not even getting anything done. It might seem that way, but there's been a ton of progress on research, problem solving, planning. It's really coming together now. I mean, things are starting to really look amazing, and it's coming together. It's exciting for me. Exciting times. All right, peace out, boys.